right, I think I'm going to start so we don't get too late. Welcome everyone to the AIA Long Island chapter monthly event. My name is Graciela Carrillo. I'm the chapter's president. And today we're happy to host Run DMC, how the offsite modular design manufacture construct project delivery method is transforming the traditional design bid build process. Before we start the lecture, I would like to make a few announcements. Next week on November 18, the Women in Architecture is hosting in collaboration with the Equity Committee by WILD for the AIA DC chapter, Global Collaboration, the Future Workplace. And on November 19, we will be hosting the Mystifying Fellowship, which is a great lecture for those of you that are planning to apply for AIA Fellowship. Also, in December, the first week in December, we will be hosting the Archie Awards ceremony. We received 87 entries, and we're looking forward to broadcast this event online for the first time. So please keep an eye for an email to register and watch the live party of the awards ceremony. Finally, the Emerging Professional Committee started the mentorship program last month, and it will be a final event to wrap up the program during, I think, late November. So keep an eye too. It's going to be a panel discussion for those of you that are interested in mentoring. Now I would like to introduce Tom Scotto, AIA. Tom is the chapter's board director, and he's also the chair of the programs committee. I'm going to turn it on to you, Tom. Thank you.
Thank you, Grace. Good evening, everyone. Thanks for joining us. As Grace said, my name is Tom Scotto. This is my first year on the board and working with the organization, and it's been great. There's a lot of new stuff and great stuff under Grace's leadership, along with the rest of the board, that I'm very excited to be part of. So I thank everybody for joining us. It's going to be a great webinar tonight on modular and how it's transforming, the traditional design bid build process. Before we begin, I just want to make sure everybody understands. If there's any questions, please, you'll see on the bottom of your screen, click that. Jeremy is going to answer them at the end of the presentation. So please don't be shy. Send them to me and we'll get them read and answered. So with no further ado, Jeremy is the Chief Design Officer of FullStack Modular. He holds a graduate from Harvard and an undergrad from Harvard and a graduate master's from Princeton. So Jeremy, welcome. We thank you for
Thanks, everybody.
And we look forward to your presentation.
Terrific, yeah, and of course in Zoom format, I can't see everybody, but it's great to be with you. I'm going to share my screen, and we're going to get going. So I realize, and I apologize, Grace, the original title was a bit of a tongue twister. But really, essentially, what this is about is how the modular DMC, design, manufacture, construct process works. And, it is anytime you hear about, modular, what is modular? How does it work? What is it doing? It's becoming more popular now, as we're seeing. I think it's been interesting in the pandemic that people have started to think, everything's been so haywire. I think in a way it's opened people's minds to trying something new that may work. So we've seen an interesting uptick in interest and people seeking us out. But of course, with the pandemic and all the attendant difficulties that is presented, it's an interesting time. So just a little bit about us. We're based in the Brooklyn Navy Yard. We're one of the leading innovators in the design, manufacture, and construction of mid and high-rise modular buildings in urban environments. And also, our approach is technology-driven, fully integrated, and radically efficient. So we can build complex projects faster with less disruption, lower cost, higher quality, and importantly for us now, a smaller carbon footprint. Essentially, the first question that really needs to come to the table, a lot of people are asking, like, what is modular? What does it mean to make a modular building? And kind of the first initial very broad description is essentially it's building something in a factory. It is manufacturing something, something in pieces that can then be brought to site. And of course, so many of the industries today are manufactured in factories and then delivered to a site. The modular we're going to be talking about, and I think the one that is seeing a massive growth and it has potential for massive growth, is the multifamily and sort of larger scale modular. So within this conversation, there is another whole set of this for a modular single family home. There are pluses and minuses to that approach to modular. We're not going to get into that here. So when we're talking about modular in this conversation, we're going to be talking about sort of multifamily structures. You can see, stuff is happening in Europe and has been happening for some time and is now just beginning to happen in the United States. Two notable projects in New York were the micro housing project, which was actually designed by my friend Mimi Huang from N Architects, and the project that FullStack was born out of, which is the 461 Dean Street by the Barclays Center, which is currently the tallest modular building in North America. Also, when we think about modular companies all have different approaches and sort of different strengths in terms of what they do. So when you think about, first of all, how the mod is made, and the two options on the market currently are wood and steel, and then how much of the process is integrated. So for instance, how much of the building does the modular builder actually build and deliver to the site? So for instance, in FullStack's case, we build higher than any other modular company, and we also integrate more. Other companies choose a business model that does not do that. And frankly, right now within the modular industry, we're seeing a winnowing of companies due to different business models. So it's interesting to see what will come out of this, current marketplace and how it will work. The two sides to modular, there is the factory side, what gets built in the factory, as I was saying, and then what happens in the field. So these are sort of all kind of some basic, just sort of basic ways to understand modular. And this is a photo of our factory with Dean Street underway. The other thing about modular is basically the delivery system for the building, for the units. And modular buildings are built out of, essentially, we sometimes even say it's like Legos. You have boxes that stack, and that box will have a Mateline where it joins the other box. It will have a chassis. Some are wood, like I was saying before. In our case, we're going to focus on the steel chassis modular system in this presentation. And a lot of what then goes into that chassis is built as an assembly and a sub-assembly. And so, from a chassis to a bathroom to carpentry, to sort of full finishing to an enclosure, all of those things will be installed in that box and then delivered to the site and then stacked. And we'll go over that process a little more in depth. The key to all this, and if there's like one slide that really kind of sums up what the initial title was about, it's this, design, bid, build versus design, manufacture, construct. And, right now, what typically happens, we have a design process as architects. They go to bid, that bid is too high, it is value engineered, it is revised, and in this cycle is a lot of time. And then it gets built. What's interesting about this model is preliminary costs are basically established. I mean, there's certainly a budget all through the design process, but really the preliminary cost is established, once that first bid comes in. The final cost, after change orders, et cetera, is established here almost by the time the building is complete. What the modular design, manufacture, construct process tries to do is design with modules, with structures, with concepts, with even finishes and fixtures, that the cost is already known. And so therefore a primary cost can be established much earlier. And then a final cost established for the manufacture and construction with the GMP at this point. In the models that we're looking at and that McKinsey, sort of vetted over last summer, or the summer before, excuse me, June 2019, it is looking that up to 50% of the time can be saved and 20% of cost savings can be had. So this is sort of the holy grail that really we're chasing, saving time and money, but also designing buildings with greater efficiency. Here's some of the things that design, manufacture, construct, sort of what we're looking to do with it. A 25% max lower building cost, 20 to 50% faster development, 70% safer working conditions, 80% greater time cost and cost certainty. And this is an interesting one because, going back to, because we can establish a cost based on, vetted models and lists at this point earlier, the cost certainty of projects for developers is very attractive. And so they really can set up their models with less disruption. Also, speaking of disruption, there's less neighborhood disruption, and also 67% less waste. Because a modular building is built faster, and also because its major building components are assembled off-site and then assembled on-site very quickly. For instance, we can stack 10 to 15 mods a day. There's a lot less neighborhood disruption. Interestingly for us, and this is, I think, maybe for another discussion, but I put it here, how you contract that design, manufacture, construct services is still very, very much something we're trying to get right. And so in our current arrangement, we typically will do an analysis and initial estimate before we engage with a formal contract. We will then go to a modular blueprint agreement, which basically takes us through a schematic plus. We call it an engineered schematic, where at this point we have 80% cost certainty. And then the final stage, the modular construction agreement, takes us through the remaining parts of design and then through to construction. Design, manufacture, construct. We're going to talk about each of the phases. The first is design. Modular analysis and design for manufacture and integrated digital workflows are sort of all happening all the time in our process. And a lot of the ways to think about a modular building is in many, many ways, it is a manufactured product. And so therefore, it really wants to have a logic and an ability to be replicated. So what we've done is, for projects that we design in-house, we've developed a series of flexible components. And the goal in this design process is to have the fewest different components necessary. In a way, designing a modular building, this sort of way we talk about it, it's like a bunch of information is going in and spitting out a building. And the more elegant and clean and precise and not wasted and efficient that code is that's going in, so there is the fewest discrete parts, the more successful that building can be. Interestingly, like when you read about modernism and the theory of modern architecture, there's a lot of that inscribed in it. But that's more of a history lecture, so we'll avoid that. What we do then is with our flexible components, which can create all sorts of different layouts, we then make unit types out of them, and then can basically organize unit combinations very rapidly and quickly. We have a parametric system set up for that organization, which, if we have time, I can preview at the end. but I want to sort of move through this and get you through the main lecture. Also, everything going into the chassis is thought of as a sub-assembly. So the kitchens are, sub-assemblies with their sub-assemblies. The bathrooms are the same. The facade is also a sub-assembly. Typically, facades will be fabricated in a separate facade manufacturer and then brought to the factory and made part of the final assembly. A couple other things that are interesting about, that sort of modular design kind of thinks about, and some of the, I think the innovations FullStack has come up with are, one, our structural system, which we'll describe in a second. Self-sealing facades are really important for us. Essentially, when you stack a building, when you use our mod to stack a building, the result is that it is then watertight. The mods stack and seal, they're self-sealing. So that means we don't need to bring a scaffolding back to seal up the exterior of the building. We also sort of are engaged constantly in developing our design technology, whether it's parametric design, integration of that design into the factory floor and into the site management, as well as sort of incubation with a bunch of other, like-minded software producers or technological producers. We also, and we learned this some ways the hard way on Dean Street, but of course, in manufacturing, you're always trying to make something better. Dimensional accuracy is the key to this. And so we typically operate with a tolerance of 1/8 of an inch. And everything we do starts with a laser metrology to assure that all of the mods are within those parameters. We also use drones to do a site metrology so that we can measure a poured foundation and figure out where it is off so that we can make adjustments both with our adjustable pieces and also within the mod sort of shimming itself. Also within the design process, we're always thinking about flexibility, like how does one chassis system create 6 different automobiles? So, for instance, with our chassis, all of the different kinds of facades that we can apply to this. And that's sort of important. And that sort of comes through in the work that, our sort of recent work. This is Dean Street in Brooklyn. And then 581 Grant, which is a project we've been working on with Think Architects in Brooklyn in the Cypress Hill neighborhood. We also have, a 6-story walk-up in Harlem and an 11-story building in Queens, to name a few. So then the manufacturing side of things. So typically, we start with the chassis. It's the building block of the system. It's the first thing that goes onto the floor. It is made out of steel, and we've been working with Arup for the last 5-6 years on creating a very robust system that has sort of built-in logic so that when we engage each project, we have a starting point already in our design that can then quickly be oriented to that design's needs. And then, of course, sub-assemblies, which we're going to work with to create all the things that will then go on to the assembly, like as I was saying. And a lot of what we do starts like this. We will work with the architect or sometimes in-house to create a very, very robust Revit model. And the Revit model is basically the key. We're going to be making, I'd say we have almost the bolts in this model of where everything will go. And then that Revit model will be exploded into our, well, I guess not exploded, I guess carefully, carefully positioned into our fabrication documents. So the ceiling framing will come in as a ceiling framing document. A wall finishes will come in as a wall finishes document. Plan and fixture types will all come out. And so, where a typical architecture set may be, I don't know, 80 pages. A fabrication set may be 300, 400 pages. And so this is why repetition is key. And any time we can copy something, we can use it again in a design is better and faster and more efficient. Now, of course, we also strive to make sure that we're not losing the elegance or the power of the buildings we're working on. There's an adverse reaction to modular as to cookie cutter, and so we have to fight that all the time. But at the same time, there's a subtle give and take about how much variation you want and how do you make really strong, smart decisions early on in the design that pay off with great results, but also keep it very efficient. And this is a good description of like the level of detail that our Revit model will contain and therefore give us in the field, or sorry, on the factory floor. This also, sorry, this is sort of an important slide. This amount of detail is also designed to use a workforce that is not at, sort of the master level. So we do not need master carpenters, master plumbers in the factory floor. The trades are represented, but they're also, because of the design documentation and because of the fabrication documents, the instructions are very, very clear and very robust. We also, from that Revit model, extract a bill of materials. So here's an example of, and it's fascinating to be, an architect. I've been an architect for 20 years, but to really go from designing, let's say, a bathroom to at the end of my design sort of handoff is a list like this, which basically is categorizing every single piece in that bathroom for ordering and for procurement. And what's really eye-opening is so much of manufacturing is procurement. You have to decide what the material is, but you also have to get it to the factory. And this has become a very interesting learning process for me as an architect moving into this space, sort of the power of it, and also how procurement shapes design. Certain things are available, certain things are not available in certain timeframes. And so how we develop the supply chain as architects actually becomes an interesting question, and one that when you sit in the sort of modular design chair becomes very apparent very quickly. So then the chassis itself, steel welded. We've actually refined this design and simplified it with Arup. This was the chassis used in Dean Street, but we now operate with basically a 6-column structure. We've taken away the straps, which tend to flap when the trucks were driving down the highway at speed. These would start to vibrate, and it would get a little crazy. So now we typically have 6 columns on each side, 1, 2, 3, 4, 5, 6. Those will transfer all the way to the ground. And it's a very, very simple system. Also, a lesson learned from Dean Street. Triangle mods do not work. This was actually a real nightmare when it went into getting it right. It was gotten right, but you learn quickly, like, this is not ideal. Also, the fact that there were mods turning in this way was also not ideal. And so we try to work through buildings with a very, very straightforward grid system as best we can. Here's the factory staging. This is sort of the floor plan of the factory and how each type of mod was sort of set up, constructed, put on a truck, and then brought to site and stacked. So this process would be ongoing. And here's some images of that happening. You can see, this, for instance, this wall here, or this framing here, would have been, which I'll show you in a second, would have been constructed from a fabrication document on a table and then brought to here to be assembled. So it would not be assembled stick by stick. It would be sort of fabricated as a whole, and multiples of these would be fabricated at once. We'll get to that in a second. So the order is structural steel, pod assembly, framing, and MEP then goes in. The kitchen, the gyp walls, and then the finishes and the facades are the last thing we put on in our process as we build out the mods. And MEP, we actually have a high level of completion of the MEP. And typically in the building, there is a single chase, typically in the hallway, which runs the length of the building. And then, of course, interior finishes are all done in the factory. Here's that framing table I was discussing. And again, one worker will work on multiple of these in a day. As mods get repeated, they'll be measuring from a simple layout set, which will dimension to each edge and very quickly be assembled. And here's that sort of staging. You can see how multiples have been created, labeled, and there's an extensive QAQC process which identifies each assembly or sub-assembly, locates it, checks it, makes sure it's completed correctly, and then assigns a yes that it can go into the assembly. Here are bathroom pods being assembled. And then here's the facade being put on with the gyp as well going up inside. Again, lots of sort of classic manufacturing QAQC processes involved. And then once we're ready, that mod gets picked up from the floor and brought out to be put on transport to the site. And then it becomes part of the construction. So, construction involves transport. Transport really is the key to modular. It is the limiting factor of a modular, of a mod, essentially. So we work within dimensions of, 16 is the max, but typically you don't want to go over 14 because then you are an oversized load, which requires a lot more expense. So typically we're working within a 14-foot wide chassis or mod. And from that, the longest we can make is 56 feet. Some sites will not allow that just in terms of logistics. So, mods will be anywhere from, 30 to 40 to 50 feet somewhere within that range. Mid to high 30s is typical. So, field work. Now we're, now we're in the construct part of the talk. The beginning is, of course, incredibly typical. So this is where the typical construction process is engaged. There's excavation, there's foundation, utilities are brought in, and in many modular buildings, the first floor with its longer spans is often, or can often be, traditionally built. Whether we need a brace frame or not, our modular system up to 18 stories does not require a brace frame in a non-seismic area. And so the mods themselves create all of the structure. Once we're now working on a project in Los Angeles, which has high seismic activity. And so we're working with Arup on a brace frame for that. It's a 15-story building, which needs to drift considerably. And then the module erection and the Mateline connections. So obviously this thing is coming and boxes have been stacked. And the last part of the construction is those gaps between the stacked boxes are filled in and made good. Typically, from a cost perspective, the field work is roughly 40% of the cost and the factory work 60% of the cost. Though depending on whether the first floor is modular, this can change slightly. Site structure, in this case, Dean Street had a plinth, a structural steel plinth, and also needed a transfer, so it was pretty robust. But this is typically how we'll set up the base. Obviously not with all of this complication, but typically we want a flat structural table that the mods are going to stack on. And here you can see that base and some of that staging, those sort of first stacking happening. Typically the mods travel overnight. So we like to send, 15 a day to the site, and they get on the truck, they head out and are there queued up for stacking in the morning. So we typically don't like to bring mods and just drop them off. You always want to lift the fewest amount of times possible. So we like to lift onto the truck, then lift when we get to the site and place. And so there you're seeing some of the first two getting placed out on the site here. And then the stacking, as the building gets higher, the crane gets higher or has been, erected to the height it needs to be. And then, mods are brought up and stacked. Here you can see the mods negotiating the brace framing to be stacked in the proper place. And this, just a little bit about our structure. So this is a typical, this is sort of a meeting point of 4 mods. And here is their corner column. Believe it's a 6x6, which is typical for Dean. And the way they work is they're not only in compression, but they're also in tension. And what we do is we have a threaded rod that runs down the middle of each column, each hollow column. So the threaded rod will be there. This is, I'm going to take you through sort of a brief description of how these connect. So this is obviously in section. The threaded rod is now poking through the steel post. The first thing that happens is bolts are rolled down to the proper location, and then the connecting plate is placed on top of all 4 of the chassis posts. And then the top bolts are placed. So that top plate is bolted to each chassis as well as to the threaded rod. The threaded rod now grabs it. And then the next threaded rod is installed, and then further, and then the next mod is placed, and the process repeats. This allows us to keep the building both in compression and tension. So these, this process allows us to tighten these up and assure that the connections perform structurally in a very advantageous way. The last is the MEP Mateline. So in this case, you're seeing an MEP chase, and all of the sort of non-bright MEP work will have been installed in the factory. Then in the site, these pieces will be installed and connected, as well as an interior Mateline set. So you can see where the floor has been removed so that once they're connected, that Mateline piece can be put back in and everything can be sealed up and made good. Interestingly, on-site inspections. So when we work with the on-site inspector sees anything built in the factory as an as-built. So the drawings almost read as if this was a renovation at this point. And so what they'll be doing is they'll be looking at any field work that has been done, and they do not need to inspect the plumbing that has been installed or the electrical that has been installed in the factory, which is all certified by a third-party inspector, which is handled by the state. And so you can see sort of the difference between the field installed and the pod installed or the mod installed. Here's a section through the lower chassis points, the upper chassis for the lower mod, and the cavity there. And then, some of the things that they'll be looking for in on-site inspections. Also, we'll need to have horizontal connections made. So typically with sprinkler pipes, those are then connected as well across the mod. Sometimes we will have an entire sprinkler pipe installed in the field if it makes more sense. But this is sort of a good, you can kind of see all the different systems in place here. And then, we also, as a modular, the sort of the dream of modular is that, and in fact, the challenge of modular it's sort of like, designing the first light bulb, probably cost Edison a lot of money, but once he got that light bulb and he could mass produce it, the rest of the light bulbs, it was amazing. So we're working in the same way. It's like when you do that first prototype, especially if it's a typology that can, well, only if it's a typology that can be repeated. And we're really trying to work on that. How do you find a situation with a developer or with your own company that you can not only design a project for someone and build that project, but how can you design a project that you can repeat over and over again? Because once you have that fabrication set of documents and that fabrication process ironed out, to make another one is even quicker. And then to make a third one is even faster than that. So there is not only an efficiency of scale in the actual building itself, but in doing multiples of that building is where the real efficiencies begins to be very, very apparent. So what we do is after the building is completed, we have a product library created out of the project design information. So if a client comes back, we have everything ready to go for another build, and any changes that need to be made to the original can be done directly. There's also, the desire to sort of work both with post-construction analysis and a digital twin for operations and maintenance. Because our models are so robust, we're finding there may be an additional product to offer a developer in that, with smart buildings, with attaching sensors to various parts of the building and learning to monitor them and run them efficiently, that can also be queued to a real-time digital twin for building maintenance and operation, something that's in development. Also, we've been responding to COVID, and I think modular has a unique sort of thought process in terms of creating smaller scale objects, but that scale that you repeat and repeat. And one has been a recent prototype currently on the factory floor is the mobile isolation unit or the mobile testing unit, made out of a series of shipping containers, which are an interesting chassis to work with. And then we've also been working with the major food group in New York on an outdoor dining unit or a dining module, which essentially is a pavilion for open air dining, but we hope, can create a more, it was actually just an article in the New York Times yesterday about, people eating outdoors and are they going to eat outdoors? So we're very interested in sort of making a module that can assist in that process. And then excited to open up for questions. I wanted to just quickly show something on our website, just going back, I think we have a second. I'm not going to take very long so that we can get to questions, but wanted to show you sort of our initial parametric. And again, this is a sort of early development, but a sort of client-facing product, which helps us. We call it our design layout tool. And so you can do this at home if you like. So FullStackModular.com and under the design heading. And essentially what it does is it takes that that sort of unit type, and it allows you to start seeing what our unit type can do for your building. So let's say you have a very typical, let's say it's a 3-lot, so 75 feet wide. Perhaps the building depth it's usually 65 feet. Let's say it's that, and the height is let's do a 65 foot. What you're seeing right now is sort of those first modular decisions you're going to make, right? So the typical width is 12.4 or is it 10.4? So we're gonna make the building a little bit, have it the apartments a little bit narrower. Also, then the unit combinations, we're still trying to work out a better rubric for how to organize and display them. But within those components that this has sort of quickly assembled for us, and in this case, with 75 feet, we're still within code for a double stair. That stair could also potentially be in the middle. of the building. You know, so maybe our developer wants some studios, but mostly one bedroom. So, you know, there's our layout and our floor options, you know, floor count. Basically, we're at a 6th floor building. So, you know, if I'm the developer, I can then go look at that massing, which is actually parametric. So let's say I want to see, well, what does a wider bay count look like? You know, I can start to look at that on the facade and, you know, sort of also look at it in a more traditional kind of brick way. And then I can also start to look at the units. So, you know, if this is my basic 1 bedroom, which is typically the heart and soul of the building, you know, I can now go in, take a look. All right, what does this look like for my, you know, for my building? In a way, it seems like it'd be nice. Ceilings are pretty nice. So I've got a 10 to 10. I may be able to, you know, here I've got now some options. Let's bring that down. So here's a 70-foot high building. A 10 to 10 floor to floor in a modular building will bring you to, let's see, it's a 16-inch sandwich. So that will give me an 8'8" ceiling. So that's what you're seeing here. And I can look at, you know, I can also look at the 1 bedroom again. Check out the bathroom. And also, you know, again, in real time, decide, you know, I think this mod may be a little bit too narrow. Let's see, let's start to get a feel for it in a bigger, you know, sort of a wider variety. So that's what I've got. I think we're at 45 minutes, so I want to stop there and take questions. And I'm going to keep the deck up so we can go back to a slide if we need to reference it.
Great. Thanks, Jeremy. It was very informative. Got a bunch of questions, so that's great. Let me start here. So,
sure.
First question, is the structure just for transport of the module, or is it the final structure of the building?
The final structure of the building.
Okay.
Yep, and that's what's great about it. It's like the box is the structure. And except for the time where I mentioned we have a brace frame, which will happen in seismic areas or over 18 stories.
Nice. What are the maximum chassis dimensions, length, width, and height?
Sure. So 14 is maximum is 16, maximum length is 58, maximum height I've heard as high as 13.6, but we don't like to go over 11.4 because of low overpasses. So that's a.
Okay. Okay. Jeremy, you're speaking to the importance of maintaining tolerances. Are you experiencing any racking of the steel chassis during transportation?
Chassis are super stiff, so no. Everything. I mean, yeah, we've had really good results. You know, there hasn't been. You know, there's always something little damaged at some point, maybe on 1 or 2 mods, but it's, you know, it's within. They're extremely stiff, and the transport does not damage them.
All right. Just for that, so the lifting blocks, are they part of the design, or they get removed?
The lifting lugs are attached to the chassis and just stay within the chassis. They get buried once they're stacked. They're hidden within the cavity.
Gotcha. Okay. Does your company do custom single-family units?
Typically, no, but I would not say no to that right now, actually. We would definitely be interested with the right partners and the right clients.
To be, are access panels provided in the prefab walls in order to make the final mechanical electrical connections?
We either leave them blank and they're gypped up for those connections, or yes, it's a very good question. If at a client's request, we can put in access panels in lieu of taping and spackling them in the field.
Okay. All right. So We have a comment, so I guess to see your reaction. In traditional process, when done correctly, that typically includes the construction cost during the design. How do you react to that?
I mean, it does. My question is, how accurate is that cost? I've worked in 20 years in architecture, and every time there's been a construction cost, I've never seen it be the actual cost at the end. Of course,
Right.
like there's a cost, but I don't know how accurate or right in the end it's going to be. So hey, it may be. There may be a magic button or a magic company that can nail that, within design and get it right. I have yet to experience them.
Okay. It would be great to hear more about the parametric aspect of your system.
Sure. Right now, I mean, the key is for us, so, a lot of parametric design attention was given to creating forms, using a parametric process to create an incredibly complex shape and then be able to build that shape. We found that parametrics allow us to quickly design and assess, both in plan and section and elevation, a modular component and its efficacy within a design. So once we employ that object into our design, that object has controls. And once we adjust those controls, they adjust on all of the objects. So it's a very quick and fast way for us to sort of understand the ramifications of a design implication. And when you're working in multifamily or hospitality, or where repetition is key, it's very, very helpful. We are still very much in the beta process of figuring out how that works, and there's multiple ways we do it. There's parametrics in Revit that can be made available to us. Our current in-house is also using Rhinoceros and Grasshopper to sort of take very quickly, initial sketches and play them out in in an array and study them. If there's a more specific question about it, I'm happy to answer it too.
Okay. How is the waterproofing accomplished both horizontally and vertically between the mods?
So I should have included an image of that. It's a double rubber gasket, which basically wraps the exterior of the facade, and it's detailed in such a way that as they stack, they compress both on the side and the bottom and the top. All four sides are then in compression, and they seal up the facade.
Okay.
It's the one question we get the most from architects who sort of say, I don't believe you, that's not waterproof. But Dean has proved it out. Our Dean Street building has no leaks. There's no external water flowing into it. And we use that same double gasket system.
Okay. We got a bunch of questions asking the cost per square foot, cost to build, etc.
Those are good ones. And it's sort of, I don't like to throw out a number in a vague way. The typical thing we do is we look at the project, we look at the location, and we quote it. It's just like any job. I don't think there's a magic number for modular. But
what about for some of the buildings you showed us? Ballpark figures.
I wouldn't even begin to throw out numbers now, just because it gets misleading. And so we want to be very clear that if you're interested, we would love to look at your project and we would love to quote it right away. That's kind of how we handle it.
Okay. Are the mods connected?
But we're super psyched. Again, if anybody's interested in sending us a project, I'm happy to look at it directly and also happy to give it to our estimating department.
Okay.
I will say this too. I will say this. Competitively, if the building is under 4 stories and is going to be stick built, that's your least expensive way to do it. Anything where you have to have steel, anything over 5 stories, and especially like when you get to 12 stories, we will be the same or less than a stick-built building. The higher you go, the less we will be than a stick-built building. And the more mods you build, you know, if this is a 300 unit building and it's 15 stories, we will cost less than a traditional build.
Okay. Are the mods connected horizontally?
So their columns are not connected to each other, but they are connected horizontally at that plate that I showed in section. That plate will connect them together. So yes.
And how is the fireproofing achieved?
So we have it's a very robust system, but it's a 2-hour rating, and we use double layers of gyp and other various fireproofing materials. So the mods come with a fireproof system installed. And it's the way they stack and the way the structure is clad is all designed to be able to be built and then assembled, and then the fireproofing is achieved.
Okay. So quick question I had, you had mentioned something about a state level approval by a third party inspector.
Yep.
How does it work? How does it work if there's a local code that needs to be met? Is that something that you'll work with the architect and
Absolutely.
design? Okay.
Absolutely. In fact, you know, all of our buildings still need a permit, right?
Right.
So the design has to be permittable. You know, it's got to meet all the codes, ADA, you name it, egress, the whole thing, heights, zoning, all of that. There's no difference in a traditional building. It's just the body that says the stuff we've constructed in the factory, they say this is okay, you've constructed it okay. But in terms of a permit, that's the DOB, the local DOB that says, yes, this building is to our code.
Okay.
So each project we do, though, like some of them we design in-house with our own architects, others are designed in conjunction with an architect a developer has brought, but they all will have an AOR that will submit drawings for a permit.
Okay, and does the AOR, do you guys work with, does the third party inspector or company kind of work alongside with the architect and professional team as like a due diligence type of?
Absolutely, but the third party inspectors coming to the factory and they're looking at what we build.
Okay.
They're the sort of building inspector. In terms of code and everything else, that's the local jurisdiction, the local body. You know, so we're going to be, you know, the building in LA will go to LA's DOB for a permit, and the architect we're working with will take our Revit model I should say the Revit model, because we're all going to share it, and make sheets for that permit out of it and then submit for permit. But, you know, even tonight I was working on the layout for the units, and, you know, all of the code concerns are there, same as they would be in a traditional building.
All right. You mentioned ARUP as the structural professional. Are they associated with the company or just a consultant? And can it vary from project to project? Yeah,
so they are, I would say they're an essential component to our structural system. And so we typically wouldn't design our modular portion without them. That being said, other engineers can sometimes design the foundation or other, you know, parts of the building, but we typically don't use a different engineer for the modular chassis and the modular array. Anything affecting, you know, our modular components, we do directly with ARUP.
Great. Somebody wants to know if you have a patent on the chassis.
We do. We do. There's IP. In fact, some of the stuff I've shown tonight is definitely IP protected, but I didn't think we needed to sign NDAs because I figured we're all friends here, and you know it was going to be on screen. But yeah, no, the IP is extensive and protects, you know, especially that connection that I showed you. That's heavily IP'd, and that was developed with ARUP, who I believe is also on we may own that patent because they were a consultant for hire.
Okay. Interesting. What's the maximum number of stories that can be built, or you have been or have built?
We've built 32. I think we're looking at up to 65 as a possibility with a brace frame. So, and it's interesting because our system, like our steel chassis, is really what lets us do that. And so, you know, the company really focused on that as a solution. They wanted to be able to create a chassis system that could build higher and could build sort of more efficiently than any other system out there.
Right. How much flexibility can be built into the mod? You know, say the building owner wishes to change the facade on it, or
Total flexibility. You know, we can put almost any facade on it. Obviously, you know, really it comes down to cost. How much do you want to spend on the facade? But we have.
okay.
You
know, how well can it be altered if a year from now after it's installed, or 2 years?
The facade or the interior?
How about both? I mean, say they
Sure.
wanted to.
I mean, and
yeah.
just like a traditional building, you can go in and change. You know, if you needed to change the room layout. You know, I don't think you want to move any plumbing, just because.
Right.
Yeah, I mean, these are multifamily buildings, right? It's like, you know, when I renovated my house, I was like, yeah, the bathroom's going over here, this is going over there. In a multifamily, you know, that the MEP actually is really important in modular buildings, because especially to create efficiencies in them. And so, you know, that's pretty much set in stone and is an important sort of thing to get right early on in the design. So you're not really going to be moving bathrooms. Can you take a wall down and change a bedroom into a living room? Sure. You know, you'll have some columns to work around. You'll have, you know, stuff like you would normally.
All right. I think that's all that we have as far as questions, Jeremy. I appreciate it. I mean, the presentation was great. It was informative. For anybody that is going to be or is currently working on modular building.
It's great to present to everyone, and please feel free. My email's up right now on the screen. Please feel free to reach out to me with any other questions. I'd be happy to be in touch.
Thank you so much, Jeremy. It was a great lecture. I learned a lot. And I'm sure everyone, they had a lot of questions. So I'm sure you're probably going to get more questions from everyone. I just want to let everybody know that we are recording this session, and we're going to be posting this into the chapter's YouTube channel and on our website, in case you want to just watch it again or share with anybody else. And thank you so much, Tom, for moderating.
Oh, no problem. It was my pleasure. Thank you, Jeremy, again.
Yeah, thank you, guys. It's great to be here.
Have a great night, everybody.
Yep, take care, everyone.
Thank you.
Bye.